Assalamualaikum and hi. My name is Muhammad Azim bin Muhammad Zahir. Today, me and my group members Muhammad Aikal, Muhammad Azam Zakwan and Adina. Today we want to present about matrix. Introduction about matrix. As an agreement of a number into row and column, make your first introduction with matrix and learn about the dimension and element. A matrix is a rectangular arrangement of number into row and column. For example, matrix A has 2 row and 3 column. Matrix dimension. The dimension of a matrix is such the number of row and column of the matrix in the order. Since matrix A has 2 row and 3 column, we write its dimension as 2 by 3. Is contrast, matrix B has 3 row and 2 column, so it is a 3 by 2 matrix. When working with matrix dimension, remember row by column. Now let's move on to type of matrix. A square matrix is a matrix with the same number of row and column. N by n matrix is known as a square matrix of order. Any two square matrix of the same order can be added and multiplied. Equal matrix. Equality of matrix is a mathematical concept of matrix. Here, two or more matrix are said to be equal if they have the same dimension and all corresponding elements of the matrix are equal. Transpose matrix. The transpose of a matrix is optional by changing its row into column or equally its column into row. A rectangular array of number of functions that are arranged in the form of row and column is called a matrix. This array of number are called either entries or element of a matrix.
Application matrix. Application matrix can use in computer graphics. Matrix are used to project 3-dimensional image into 2-dimensional plane in the field of graphics. Square matrix very easily represent the linear transformation of object. Matrix operations such as translation, rotation, and sealing are used in graphics. Using matrix to manipulate a point is a common mathematical approach in video game graphics. Use of matrix in science. Matrix are used in optics science to account for refraction and reflection. Matrix are also useful in electrical circuit and quantum physics. Moreover, matrix are used to solve alternative current network equation in electrical circuit. Use of matrix in wireless communication. Matrix play a key role in signal estimation and detection problem. They are used in sensor array, signal processing, and the design of adaptive filters. The main problem is to detect and locate the radiating source given the temporal and spatial information collected from sensor, such as radar signals. Also, matrix can use in physics. Quantum mechanics, electrical circuit, and optics are all studied using matrix. It aids in battery power output, calculation, and resistor conversion of electrical energy into another useful energy. As a result, matrix play a significant role in calculation, especially when using curve, voltage, and current law to solve problems. Lastly, matrix can use in construction. The construction industry is another common application of matrix in real life. Have you ever seen a building that is straight on the outside, but the architect tried to change the structure on the outside. Matrix can be used to accomplish this. A matrix is made up of rows and columns, and the number of rows and columns in a matrix can be changed. Matrix can aid in the preservation of history structures.
This is the part 1 for matrices operation, which is addition. Addition between two matrices is feasible if and only if they have the same order or the dimension. That is, they must have the same number of rows and columns. Addition if the matrix is feasible by adding the element of another matrix if they have the same order. So this is the rule of adding matrices: A1, B1, C1, and D1 plus by A2, B2, C2, and D2 equals to A1 plus A2, B1 plus B2, and then C1 plus by C2, D1 plus by D2. So this is the properties of addition matrices. The law is, for the first, commutative law. It means that if our matrices are of the same order, then A plus B equals to B plus A. Thus, A plus B equals to B plus A. And then for the second is associative law. It means that three matrices and the matrices have the same order. So this is matrix addition 2 times 2. So alright, given A is 3, 8, negative 4, and 5. So for the B is 9, 2, negative 5, and negative 6. So let's say we want to plus the matrix that we are given. So A plus B equals to 3 plus 9, negative 4 plus by negative 5, 8 plus 2, and then 5 plus by negative 6. So we will get the answer is 12, 10, negative 9, and negative 1. So this is for 2 times 2 matrix. So let's say we have 3 times 3 matrices. So for this, we have as A is 3, 4, and negative 7, 8, 6, 1, negative 5, 2, and 3. For B is 4, negative 2, 3, 3, 8, negative 5, 7, 4, and negative 9. So let's plus the matrices we have here. So 3 will be adding by 4, 8 will be adding by 3, and negative 5 will be adding by 7. 4 plus negative 2, we put bracket here, 6 plus 8, 2 plus 4, negative 7 plus 3, and here 1 plus by negative 5. and 3 plus -9. I'm so sorry if my handwriting is not handwriting is not really good. So for the final answer for this is we will get 7, 11, 2, 2, 14, 6, -4, -4 and -6. So this is the final answer for 3 by 3. 3 times 3 matrix for adding. Okay. So got part 2, which is matrices for subtraction. So the subtraction of matrix is the subtraction between two matrices is possible if they have the same order or the dimension. So they must have the same number of rows and columns in order to subtract two or more matrices. Subtraction for matrix is possible by subtracting the element of another matrix if they have the same order. So next is the rule of subtract matrix. So it's always the same, just like before. A1, A2, A3 and A4 minus by B1, B2, B3 and B4 equals to A1 minus B1, A2 minus B2, A3 minus B3, A4 minus B4. So next is the properties of subtraction matrices. For the first law is it is a non-commutative operation if we reverse the order of the matrix and subtract both of them with the same order dimension. The result will differ, A minus B, B minus A. Second is the negative of matrix is written as negative A, such that if the addition of matrix with the negative matrix will always produce a null matrix. A plus bracket negative A equals to 0. For the next is we'll be using operation subtraction. What we got here is let's say we have J 7, -2, 8 and 3. For the K is 6, 5, -1 and 3. So this is 2 times 2 matrices. Alright, let's do this together. 7 minus by K, and we got 7 minus 6, 8 minus 5, -2 minus -1, 3 minus by 3, and then for the final answer we will have here is 1, -1, 3 and 0. That's all. It's so easy. So for the next answer, for the next question, for example, is we'll be using 2 times 3 matrix. Alright, let's do this together. Let's say we have F here. F is 2, 4, 5, -6, -9 and 3. For N is we have 7, 5, 3, -8, -6 and -4. So let's subtract this together. F subtract by N equals to 2 minus 7, 4 minus 5, 5 minus 3, -6 minus -8, negative 9 minus negative 6, 3 minus negative 4. So for the final answer for f minus n, matrices will be get negative 5, 2, negative 3, negative 1, 2, and 7. That's all.
Hi, my name is Muhammad Haikal. Now we are going to chapter 4, multiplication in matrix. Multiplication have two types of multiplication. First, we have a matrix by a single number. Second, we have a matrix by another matrix. Let me show you how to multiply a matrix by a single number. This is an example. So the calculation is 2 times 4 equals 8, 2 times 1 equals 2, 2 times 0 equals 0, 2 times negative 9 equals negative 18. We call the number a scalar, so this is called scalar multiplication. How we can multiply one matrix by another matrix? The matrix can be multiplied since the number of columns in the first one, matrix A, equal the number of rows in the second matrix, matrix B. Now we are going to Cramer's rule. Cramer's rule definition. Cramer's rule is one of the important methods applied to solve a system of equations. In this method, the values of the variable in the system are to be calculated using the determinant of matrix. Finally, Cramer's rule is also known as the determinant method. How to use Cramer's rule? 3 times 3. Let us write this equation in the form ax equal b. This is the example or the formula for Cramer's rule. Now, let's do some exercise. Question 1. The question is x plus y plus z equals 6, y plus 3z equals 11, x plus z equals 2y or x minus 2y plus z equals 0. You can pause the video if you want to do this exercise. Let me show you the solution. First, we need to turn this equation in the form ax is equal b, like this picture. After that, use the equation to find the d. Next, you can change the answer to x, y and z place. With this formula, we can find the dy, dx and dz. Finally, the answer we will divide by 9, that is d. So this is the final answer. Thank you.